see that? Do you guys understand why like this is continuous on 1, 4? What's that?
Because there's no jumps or discontinuity between 1 and 4.
Yeah. Does that make sense? If you need the endpoints locked in, because things could happen at the endpoints. You know, like you could have, for some reason, I don't know, it might streak up or something, for whatever reason. But you have to have the endpoints, otherwise it doesn't work. Okay? All right, yes?
So it's like saying, like, kind of like in math context, like, if you went from the first floor to the 6th floor, and you didn't, like, jump anything, then you hit everything.
Yeah, yeah. If you're on the elevator, you didn't, like, use the Star Trek beam me up from the 1st to the 5th. You went 2, then 3, then 4, then 5. Does that make sense? You didn't skip a floor. You didn't, like, you know, beam, like, oops, you know. You hit every floor on the way up. Does that make sense, you guys? That's what it's saying. So right now it's like, kind of, oh, okay, what's the point? Well, like, on the AP test, these questions come up. And it just wants to know is, can you prove that there is a 0 in this function? You know what I'm saying? In the previous one. And you could. If you need to prove that there is a solution, meaning the y value equals 0, that would be a way to prove it. Without actually calculating. It doesn't help you calculate it at all. It just helps you prove that one exists. Yes?
So how does the actual proof look like?
Great. I think we're going to do one in a second. Let me just write it for this one, though. So the other one was this. I'll just draw it kind of. Okay. So here's how you would write it. That's what we're going to practice as we go on. You have, say this, even the picture, I don't even know what the function is, I just have a picture, but I call that f of x. Okay? If they tell me, which either we see or it's written explicitly, that f of x is continuous on the closed interval 1, 4. Since f of 1, hold on, let me finish this up. F of 1 equals -2. F of 4 equals 3. By IVT, intermediate value theorem, and then you can either write all this out, but I'll do the math terms for it. There exists a point C such that f of c equals 0. Would be one way to write it out. What this says is there exists a point C such that f of c equals 0. But what you would need, what the grader would be looking for, if this was a question like, can you just prove this? They would need to see this, 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 and that in order to say that. They need all of those pieces. You need to say IVT, you need to say continuous on the closed interval, and you need to state explicitly the 2 endpoints. Okay? And then that's all you need to do. If you get that information down, by IVT, you've proven it. Okay? By the intermediate value theorem. Does that make sense? And that's how you would write it out. And again, that's something we're definitely going to be practicing with a couple other theorems too as we go on. Okay? Sign it. Do you have a question? Okay. All right. So that's intermediate value theorem. We're going to look at another example in a second. So let's take a look at this graph right here. So here's a piecewise function, and I have a question. I have a piecewise drawn here. All right, with the different pieces: x squared plus 3, 10 minus x, 6x minus x squared, and I added in the 10 minus x as equal to on that part. Where x is greater or equal to 1, less or equal to 2. So here you have this piecewise defined function. All of those pieces by themselves are continuous. So, you know, x squared plus 3, that's continuous. You know, like it's a continuous function. So everywhere on x squared plus 3, the limit value is going to equal to the function value. 10 minus x is a line, you know, and on all the real numbers. 6x minus x squared is a parabola. It's a continuous function, and it's continuous on any interval. So the only thing you have to check or be careful about with these piecewise is, again, where you connect up. Okay, does that make sense? So let's look at the different points. So the first connection point is 1. So at x equals 1, well, what's the limit as x approaches 1 from the left?
4.
Yeah. What's the limit as x approaches 1 from the right? What does that mean about the limit? Since the limit from the left doesn't equal the limit from the right, the limit does not exist. What does that say then about continuity at 1? Yeah, if the limit doesn't exist, it can't be continuous there. Does that make sense? You don't even have to check the function value. Since f1 is 9, who cares? Since the limit already doesn't exist, it is not continuous. It's a done deal. Because the limit value, you have to have a value for the limit, meaning it has to exist. The limit value has to equal the function value. So the limit doesn't exist at 1. And then it's like, okay, what type of discontinuity is it? In that case, it's a what? It's a jump. Okay? What about at 2? What's the limit as x approaches 2 from the left? 8, it looks like. Yeah, that sounds right, because 10 minus 2 would be 8. And again, you can directly substitute into that function from the left side. Does that make sense? Again, you don't need the picture. If you want to know from the left side, dump it into the function going at it from the left side. You know, even though it's not included, it's still like where that line is going. Does that make sense? Okay, so the limit from the left is 8. What's the limit as x approaches 2 from the right? Also 8. Again, if you plugged it in, it would be 6 times 2 is 12, minus 4 is 8. If you plugged it into that function. So what does that mean about the limit as x approaches 2? It exists, and it's equal to 8. The limit value equals 8. What does the function value equal? 8. What does that mean in terms of continuity? It is continuous. Since the limit value equals the function value, this function is continuous at x equals 2. Yes?
I have a question.
Okay.
So, even, like, for when it's a jump, like when it's not continuous, what would be the function value for that?
So it's where it's determined by, in this case, I drew those little equal signs. You could have drawn them both open. That could have been the function. In this case, it's where is the function, what rule does it follow? Well, at 1, it follows the line. You see where it says like x is greater than equal to 1, less than or equal to 2?
Mm-hmm.
Right there. So since it follows that line rule, the 10 minus x and that, you would plug in the x value into that function. Does that make sense?
Into the 10 minus x?
Yes, because that's where it's, for a piecewise, it's you have to follow, for what x values does it follow which rule? For 1, it's following the 10 minus x rule, so you'd plug in the 1 into that function. Does that make sense? Great question. Okay? Looking at a couple of these other examples down here. You know, example 1, you have an infinite discontinuity at -2. Even though it shoots up from both sides, that's still considered an infinite discontinuity at -2. So now I want to spend some time talking about this example 2 for a second, okay? It's the function, if you want to graph it, there's a picture of it right here. X minus 1 over x squared minus 4x plus 3. So here's a picture of it, and I want to determine different places if it's continuous or not, okay? Well, first let's plug in x equals 3 into the function. At x equals 3, this thing is going to equal 3 minus 1 over 3 squared, 9, minus 12 plus 3, which equals 2 over 0, which means what? Ego man, undefined. You have a number divided by 0. Here's where you're going to have that infinite discontinuity every time that happens, okay?